off.
Awesome.
So I can see your screen, yeah, I can see Scott's screen. Off.
Awesome.
All right, I'm off. Have fun. See you on the other side. So I can see.
Awesome. Okay, maybe we'll give people a few more minutes to trickle in here.
Scott, do you want me to start admitting people?
Yeah.
Okay.
Yeah. I realize those. All right, well, we could probably go ahead and get started here. I'd like to say hello, everyone. My name is Scott Feehan. I'm a PhD student at the University of Nevada, Reno. And along with my growing list of co-organizers, I would like to welcome you to EPSP Connects. And thank you for joining us for our final installment of the year. We'll be taking a short break for the month of December while we all attend AGU, and then we'll return in January with Science Talk from Danica Roth. But today, we would like to continue on with our conversation around environmental justice with the demographics of dam removal from Dr. Josh Galster. Dr. Galster started his academic career by completing his bachelor's degree in geology at Carleton College. And then he went on to the University of Vermont, where he received his master's. And then finally at the University, or Lehigh University rather, he received his PhD, and since then has been a professor at Montclair State University. And I would like to turn it over now to you, Dr. Galster. We'll stop sharing my screen. You to take over.
All right, let me do that and do that. All right, thank you so much, Scott, for that introduction. Thank you, everyone, for the organizers for inviting me this morning, and thank you, everybody, for coming this morning or this afternoon or wherever, whatever time zone it might be where you're at. So I'm really happy to be here and share some of these exciting results that myself and my co-author with that coincidental last name, which I'll explain a little bit later, have. And so we've been really excited to have some of this work get to the stage where we can talk about it to a broader audience. So thank you so much. So this is a picture that the local newspaper took of me doing some work in some streams. And this was, let's see if I can move my Zoom screen out. This was the caption that I found to be pretty funny that the newspaper put along with it. Apparently taking some kind of measurement. I think that's what the dean mostly thinks that I do when I do field work. I don't know if anyone else has that challenge of explaining what field work is to some others. But it was when I was taking some kind of measurement there, it was a total station, we were measuring cross sections, that I got to start thinking about dam removals and how dam removals are these intentional disturbances to river systems. And we disturb them because they should have some kind of net benefit. And if they don't have a net benefit, then one wonders kind of why we're doing this. And so these benefits might be across the biological or physical or chemical kind of metrics that typically get measured when dams get removed. But I was wondering, and my mind tends to wander when I do field work, as I'm sure it does for some of you, who are these local populations around these dam removals? Who are they? And so it was around this dam removal project that I started to think about these local demographics. This was at a dam removal project in Northwest New Jersey, fairly close to the Delaware River water gap, if some of you are familiar with that region. And you know, I started to think about more of the kind of environmental justice context and thinking about whether these dam removals are concentrated in certain areas or are they concentrated near certain populations, certain types of communities. And I'm certainly not an expert in environmental justice, but the way I was thinking of it was that, you know, environmental justice tends to analyze what are the groups, what are the communities that share the costs, and what are the groups that share the benefits of these environmental actions? And, you know, a lot of times we talk about the environmental costs, whether that's water pollution or landfills or, you know, air pollution or noise or what have you. In this case, it's kind of the inverse of that, where it's the environmental benefits. And so what group of populations are enjoying the benefits from this? So, taking a big broad view first. So where are the dams in the United States? If we're going to talk about dam removals and compare those to the dams, well, then we first at least should have an introduction to where dams are in the United States. So this is a GIS map, and those are yellow dots. Those are dots. Those aren't just you know, a blanket of color, but those dots are so dense because we have over 90,000 dams here in the United States. That is from the United States Army Corps of Engineers, the National Inventory of Dams. That does include dams in Hawaii and Alaska. I just did the sort of lazy cartography map, issue for this map and didn't include them. I apologize. And of course, there's that paper by Will Graff in 1999 that I think is my favorite title of all time, and includes an inventory of the dams in the United States. And one of the numbers that sticks with me is that if we were to take that reservoir volume behind the dams in the nation, and if we could somehow divide them up by each of us, and so if each of us were to get sort of a portion of that reservoir capacity, then we'd have about 5,000 cubic meters per person in potential reservoir volume behind US dams. So we have a lot of dams and we have a lot of storage capacity behind dams. How about dam removals? Well, these have been increasing recently, not surprisingly. So this is a map of, a graph of cumulative dam removals in the United States. And you can see that that is increasing exponentially. I think Excel wanted me to fit a 70-second power function to that, which probably isn't realistic, but still, they are increasing at a pretty rapid rate. And we're just at about 1,400 cumulative dam removals so far in the United States. And that came from an American Rivers Dam Removal Database that was published in 2018. And so here we have those cumulative dam removals now color-coded according to age. And so the gray dots are the ones that happened before the year 2000. The light blue dots are the ones that happened between 2000 and 2009. And those purple dots are 2010 to 2018. And so you can start to see that these dam removals are not spread evenly across the United States. Certain regions, certain states have a higher concentration of dam removals than others. 2 states have had 0 dam removals. That would be Oklahoma and Mississippi. And so we're going to concentrate in this study on the purple dots. So we're going to look at the last basically 9 years worth of data, so 2010 to 2018, and the dam removals that have happened in that time period. So it's the most recent ones that the data I'm going to show you are going to be talking about. Here's some data from a paper from Belmore et al. 2017. That kind of reddish brown curve is similar to what I just showed you. It's just a few years older. And so those are the cumulative dam removals that are increasing going up that way. And the sort of take-home message from this graph is that there are dam removals that are studied, but most of those studies are kind of sparse. There haven't been that many. The studies are listed in the lower right there. It's those dark gray columns going down from the horizontal axis. So the studies are 10s and 20s of studies, even though we're above 1,000 dam removals. And most of those dams removed are pretty small. So the dam removed in the top left are those bar charts. And again, that kind of reddish brown color shows you the height and the percentage. Most of those dams removed are certainly under 8 meters tall. So the smaller dams are being removed, and they're not very well studied, even though we have lots of studies. And those studies that do exist, what Belmore did was analyze the different studies and looked at what metrics those studies used to try and get at the impacts of the dam removals. And for those of you familiar with this topic, there are the kind of usual suspects. They talk about water quality, decreases in temperature, dissolved oxygen, turbidity, et cetera. Whether it's biological metrics, fish being present, fish habitat, fish passage for migratory fish, as well as physical metrics. So it's substrate size, river depth, river discharge, etc. You know, when I've worked on dam removals, I've been on the far right. I've been on the ones, you know, doing pebble counts, measuring cross sections, doing things like that. So those are the traditional ways of doing it. But these social issues and social impacts were not included in this study. And that's fairly typical that we haven't looked at those broader issues. So we had a couple of research questions. And our first question was that, is the racial and ethnic composition of census tracts that have had dam removals significantly different from those that have not had dam removals, but have a dam? So the ones that have a dam, are those different from the ones where a dam removal has occurred? And we're going to compare the census tract demographics between those two. And again, those dam removals are those last 9 years, so 2010 to the present. So that's question one, a pretty straightforward one. Is the racial and ethnic composition of census tracts with dam removals different? And this will lead to question two. Does the association of the census tract, of the racial and ethnic composition of the census tract, affect the probability of the dam being removed after variables of that dam are controlled? So after things like the age of the dam, the height of the dam, its type, or what it's made out of, basically, what's its construction material, as well as what's the dam's purpose. Is it used for hydropower? Is it used for irrigation, etc.? And so that is going to use this ordinary least squares method to try and determine which variables are important when predicting dam removals. So those are our two research questions that we're going to share how we did today. There we go. Okay, so census tract data. A little bit of background on this, since I learned a lot when I started to explore census tract data. So the goal of a census tract is that it should have about 4,000 people in it. And because of this goal, census tracts will change over time. So a census tract that existed in 2000 may be slightly different in 2010. So the size will vary with the population density. If it's a highly dense area, if it's a city, then the census tract will be pretty small. And if it's a pretty sparsely populated area, the census tract could be quite large. So here is a map of Arizona. Outlined in white are those different census tracts. You can see the size in the center of Arizona is Phoenix. Down to the southeast a bit of Phoenix is Tucson. So those areas have much denser census tracts because a lot of people live there. Other areas of Arizona have really big census tracts because very few people live there. And the census tract collects racial characteristics, and those are self-identified. So people will fill in the boxes, and many of us, I hope, completed our census forms recently in the last few months. And so those are the data that get collected every 10 years. So we're using the 2010 census tract data since that's the most recently available, at least for now. So what I did was I first selected the census tracts with a dam removal. And so here we had a map of the United States. Those census tracts in yellow are the ones that have had a dam removal. And so we wanted to see what was the percentage of non-Hispanic white residents in those census tracts. So it compared those with census tracts with dams. And so that's where I started with this. And what I found was that on a state-by-state basis, the dam removals have occurred in census tracts with a higher percentage of white residents than the state has overall. And so let me explain this graph on the right. On the horizontal axis is the total population of that state that is white. And on the vertical axis is the population of the white residents that have had a dam removal. And so if you are above and to the left of that line, then you're in a region that has whiter residents, more white residents than the state overall. And if you're on the bottom right, you have less white and you're more diverse. So we had 45 out of 48 states had a higher percentage of white residents around dam removals. The three states that not are Rhode Island, South Dakota, and West Virginia, and they had very few of the nationwide dam removals in total. Looking at my current state of New Jersey here, we are at 68% white residents as a state overall, but those dam removals occurred in 85% of had 85% white residents in those census tracts. So most of those dam removals are happening in whiter areas. But maybe it's a function of where dams are. Maybe if dams are in more rural areas and not in the cities, maybe it's just there. So then I compared the census tracts with the tracts that have had dam removals, have had dam removals and have dams. And those dots shift a little bit closer to that 1-to-1 line, to that dotted or dashed white line. But still, we have 2/3, 32 out of the 48 states had dam removals that are less diverse. And this is where I kind of got stopped with my analysis. I compared them on a state and left it at that. And then I realized, wait a second, I should contact someone who has a lot of experience analyzing data sets like this. Large data sets that deal with racial characteristics, that deal with the effects of an area or the effects of something occurring in an area. And luckily for me, I just happened to grow up with one. So my co-author, George Galster, is my father. He's an economist who recently retired from Wayne State University. He has studied a whole range of issues, including neighborhood effects on children growing up, housing discrimination. And so it's been great to work with him on this project. And so, when I'm talking about, my colleague suggested this, it's really my dad. So even though it sounds a bit like, my dad suggested this as if he's suggesting that I clean up my room, that's the language I'm going to go with. So it's been a lot of fun to work with him on this problem, on this issue. So he and I then have explored these dam removals with the environmental justice issues. And so environmental justice has documented quite clearly that communities of color are disproportionately exposed to environmental problems such as contaminated soil, contaminated air, and poor water quality. But if dam removals are a benefit, if they're a net benefit to the community, how are they distributed and what local populations are benefiting from that? Because it can also be an environmental justice issue if all the environmental benefits are being accrued by a certain population. Think about where parks are built or recreational facilities, for instance. And I don't think dam removals and the larger kind of subset of studies of river restoration studies have really addressed these environmental issues sufficiently. I don't want to say it all. I'm not aware of that many, but we haven't done a good enough job, I'm going to say. So with my colleague, my dad's help, what we did was we looked at the census tracts where dams have been removed compared to where those dams have not been removed. And we did this on a nationwide level. So with his help, we took a similar data set. So we took the American Rivers dam removal data set from 2010 to 2018. Those are those red dots on the left. And we compared that with, again, the National Inventory of Dams from the U.S. Army Corps of Engineers. That's all the yellow dots. And again, we combined it with the 2010 Census of Population and Housing from the U.S. Bureau of Census. So a similar analysis to what myself as a geomorphologist tried to do by analyzing census tract, but with a little bit more statistical expertise and sophistication. So zooming into my state of New Jersey here, here we have the census tracts in tan. We have the dam removals that have happened from 2010 to 2018 in red, and then we have existing dams in blue. And so we compared the census tracts that have had dam removals to those that have still have dams remaining. And we did that for the nationwide. So this is just a map of New Jersey to illustrate a little bit what was going on across the nation. So some data on where the dams are and where the dams have been removed. We decided to group them by region. So these are regions defined again by the US Census Bureau. So we took their regions. And so we have 4: the Northeast, the South, the Midwest, and the West. So on the left, we have the total number of dams for each region and the percentage share of the total. So the South leads the way with 44% of the dams in the region, followed by the Midwest with about 32% of those. However, the removals show a different story, whereas the Northeast doesn't even have 10% of the total dams in the nation. They've removed almost half of the dams so far. So they've removed 309 out of 669 dams, again, in the last 9 years, so 2010 to 2018. And the South has removed very few. So that last column, that percentage, that's the percentage of the dams that existed in 2010. How many of those were removed? And so in the Northeast, well, it's about 3.5% of the dams that existed in 2010 were removed in those 9 years, which is a pretty significant amount, I'd say, as opposed to the South that's removed about 0.2%. So the South has lots of dams and has removed very few, whereas the Northeast has a lot fewer dams and has removed a lot more in the last 10 years. So those are national data, all dams. If we look at a subset of that data and look at the primary purpose, as well as the construction material, the dam type, as well as the age and the height of the dam, we start to get into some other interesting trends. If you're paying really close attention, you'll notice that our sample number is decreasing here, and that's because in these data sets, not all of the fields were complete, so we discarded the ones that we were missing information from. And so you'll see that for the removals, those far right column, the most common, the most common individual use, we had this other category, multi-purpose category for the primary purpose of the dam. And so about half of those dams removed were fitting into those other category. But after that, we have about 17% of the dams removed were used for recreation, and about 11% that were removed were used for hydropower. The big ones in terms of removal type, the construction type, about 32% of those that were built out of concrete were removed, followed others by concrete with other material in it. Again, this is coming from the U.S. Army Corps of Engineers, so we went with those divisions. And the age, so that's the year of the dam completed, that is the mean, that's the average of all the dams not removed, as well as all the dams that were removed. So you can see that the average dam with the average dam age in the United States is about, or the year completed is about 1961. So basically 60 years. The removed dams are much, much older. Those average years that it was completed was 1917, so a little over 100 years. And the heights are also different. So those removed dams are much shorter. The not removed ones are basically twice as tall. So those are means of it. And so the removed dams tend to be older and shorter and tend to have hydroelectric power as one of their purposes. The demographics. We are pulling dams, we are removing dams from really white areas. So what this graph is showing is across the horizontal axis is our proportion of non-Hispanic white residents in that census tract that has had in the census tract. So you can think of those as those are proportions. You want to convert those to percent. The column on the far right is greater than 90%. And the blue are those dams that existed. So those were not removed. They're still in existence. And the orange are the ones that have been removed in the last 9 years. And you can see that almost 60% of the dams that were removed have come from areas with more than 90% non-Hispanic white residents. So that orange line is, or orange bar is much greater in that far right-hand column. Those are where the dam removals are happening. And as you scroll off to the left, those differences get a little bit offset, but we have the majority of the dam removals occurring in really white areas. So those are coming from our census tract. If we look at the demographics of this, I've put in bold the numbers that are statistically significantly different between the census tracts that had dams removed and the existing dams. So the first column is the means of the demographics of the census tracts that have had dam removals. So those are 85% white, and you compare those to the road just to the right of it, 81% is the percentage of non-Hispanic white that have dams. So we have pulled dams from whiter areas. Percentage black tends to be around existing dams, so much less black residents around dam removals. Hispanics are about equal between the two, no difference. Asians tend to live around, or tend to be more people identified as Asian around dam removals. Native Americans tend to be around existing dams, and then the other or multiple races tend to be around removing dams. So those are all statistically significant differences if they are in bold. And the far right gives you an idea of the current population if you want to set it sort of into a larger context. So those are our census tract comparisons. Cool. All right, fine. But again, this is where my dad really helped with, okay, maybe those differences can be explained though by where dams occur. As in, what if we just happen to have, either through chance or some other kind of historical trend, what if we have predominantly small dams in white areas? So if we have a lot of small dams in predominantly white areas, that could explain the difference, because we've already sort of been shown that small dams are more likely to be removed, or maybe it's older dams are more likely to be removed. So what if we control for those differences? And that's where the use of this ordinary least squares method came in. And so this is going to estimate parameters in a linear model of the probability that a dam is going to be removed in this decade, our period from 2010 to 2018. And what the ordinary least squares, or OLS, produces is a coefficient in front of each variable. And positive coefficients means that it's more likely to be removed, and negative is less likely to be removed. So this is where ordinary least squares comes in and helps us figure that out. So even when we control, so when we do that, so when only the racial and ethnic data is used, again, we still see the dams remove in whiter areas. So that was where we're at right now. We haven't applied the ordinary least squares. So we haven't gone to this extra step. However, we don't really need to demonstrate that there's been a disparate impact. So just by the data I've presented, I think there's a strong enough case to be made that even if there is some other explanation, there has been removals from whiter areas, and that's created this disparate impact, this environmental justice issue. But if we add these other variables, including region, and where these different dam removals are occurring, maybe we can get at some differences across the country, as well as some potential explanations for why there are these disparate racial impacts. So that's why we wanted to do this, to try and explore a little bit deeper what's going on with them, which leads us to our second question. So can we control for those different variables of the dam? So its purpose, is it hydropower? Is it flood control? Is it irrigation, etc.? The dam's height, the dam's age, and then the type of dam or the construction material. So is it made out of concrete? Is it made out of earth? Is it made out of whatever, masonry? So this is our second research question. And so to try and keep this a little bit more understandable, I'm just going to tell you the line, or I'm not going to show you the coefficients and keep it at this. When my dad first showed me the table of output from this stats program that I've never used, he included the email like, oh, these are some great results, don't you think? And I had no idea, in all honesty, what I was first looking at. And I think it was revenge for me making him get into some waders about 15 years ago and working in the field with me with a total station. So I think he was just waiting for me to, like, the chance to show me some statistical output. But so I have translated that somewhat and simplified it to these results. So a dam, in the last 10 years, a dam is more likely to be removed if the purpose was hydroelectric, originally listed, if it was made from either masonry or concrete with other, and then, not surprising, if it was older and if it was shorter. So those are positive coefficients in our statistical model. They are less likely to be removed if they had one of those three purposes, irrigation, flood control, or recreation, and less likely to be removed if they were made from earth, if they were an earthen dam. So those are nationwide. If we look at different regions then, the Northeast. So the Northeast had no racial differences. If we just look at those 300 or so dams, and you remember that was close to half of the dam removals, there's no racial differences at all. It completely gets removed if we just look at the Northeast. The Midwest and West, they had dam removals actually in less white areas compared to where dams are. So those were more diverse areas. So not only are the racial differences removed, they go the other way. And so those dam removals are happening in areas with fewer non-Hispanic white residents. And that controls for differences in dam age, dam height, the construction material, and purpose. So those those 4 variables are controlled for here. And so we are just looking at these regional effects at this point. Which leaves us with the South. And the South had these regional effects where the dam removals are happening from areas with way more white residents than just dams. So then we decided to look at ownership. And so we broke down those southern dam removals, and there weren't that many, thankfully, to make the analysis a little easier. And so what we grouped them into was the 2 groups. So we had dams that were owned by federal, private, and utilities. And so these did not have any differences, racial differences between those dam removals, the census tracts around those dam removals, and the dams that are still in existence. However, it was those dam removals that were owned by state and local governments that account for the racial differences in the South. Something's going on with the local governments and which dams they're choosing to remove and which dams they are not choosing to remove that's created this racial difference. Looking at some of the surrounding land use, these dams that have been removed in the South, owned by the state and local government. So those 19 dams that have a racial difference were removed from areas that had more developed open space and low intensity housing. So you can kind of think of suburban, ex-urban settings. So these are either parks, low intensity housing, so single tract houses on fairly large lots. This tends to be where those dams were removed in the South. And in terms of regulations, many southern states have very few or no laws that regulate dam removals, and dam removals are happening at this local level to a large degree driven by local decision makers. And those local decision makers have a lot of freedom when to remove dams and if to remove dams. And so we haven't gone to the level of motive, but even if that impact is unintentional, it's still discrimination in that these net benefits are being given to a different population, in this case, a much wider population. So in conclusion, to try and wrap up some of this, nationally, we have this trend where dam removals have occurred in areas with wider populations, and that's particularly true of state and locally owned dams that have dam removals in the South. We can think of dam removals as being a part of the larger topic, larger topic of river restoration and where we are doing these river restoration projects. I would love to do a similar analysis to river restoration projects. But I haven't found a comprehensive data set such as we have for dam removals. And then as a plug, I would encourage us to be more mindful of these kind of environmental justice factors when we take on our projects and ask questions and reach out and try and create partnerships. And I think there are receptive audiences and receptive collaborators out there. And so if we can venture out and go beyond taking, discharge measurements and cross sections and pebble counts and those things that we're probably, at least speaking for myself, much more comfortable doing, I think we can leverage our studies and our results to have a much broader impact and have a much more meaningful impact as well. So that is what I have. And so thank you all for sticking with me. And I'll be happy to take any questions at this point.
Well, Thank you very much, Josh. That was absolutely thought-provoking and a great talk. I'll just let everyone know we can open up the chat for questions, or if you would like to be unmuted, we can do that as well, and you can ask your question that way. I guess I can start with just a quick question off, and then we can go to Joel, as I see he can't raise his hand there. Have you thought about next steps, and do any of those involve going and speaking to these communities and seeing how it directly impacts them?
Yeah, we have thought of next steps, and there's lots left to do. And so whether it's going off into the river restoration avenue, whether it's looking at more of a case study approach and trying to figure out what's going on with these southern dam removals, there aren't that many. I have a colleague at Montclair State who has expertise in doing that. Yeah, there are lots of next steps. And so this is really my initial, foray into doing this kind of research. Like I said, usually I'm there, plotting some cross sections and looking at changes over time and doing those kinds of things. And so, yeah, there are lots of great next things to do, as well as, trying to figure out what's going on at those kind of local scales. And I think also, our regional and nationwide analysis is probably the appropriate place to start. But that graph I showed you about a quarter of the way through with all those blue dots that represented each state, there probably are some interesting stories going on at the state level that get washed out, even if we start analyzing them regionally. So
what happened?
Great, thanks so much. Joel, if you want to unmute yourself, we can go on to you for the next question.
Yeah, thanks for the awesome talk, Josh. This was a really fascinating data set. I have two questions. One's related to what Scott was getting at in the last question. And that's, could there be, no dam removals have their benefits, but they also have risks. And, one risk that I think about is if you're going to remove a dam, you have to do flood control downstream in a reasonable fashion too. So could there be, also, could that be playing a role in how this is all playing out, that, perhaps lower income communities that are downstream of dams are more at risk for flood hazards, and that's preventing these types of dam removals? And I guess my second question is related to that, which is, do you have any sense of what at the state or local level or the utility level, who decides and what they consider to remove a dam, what that process is? Sure.
Really good questions here. Let's see. I was going back to my talk so I can come up with some numbers. Yeah, I mean, you have some really good suggestions there, because very few of the dams that were removed had flood control as the primary purpose. So maybe it is a kind of hazards and who's potentially exposed to these hazards. It is my experience that most of the dams that I've seen removed are pretty defunct and not very useful for any purpose. They might have a purpose listed, but most of them have either outlived their purpose or never had much of one in the first place. Which kind of leads, I guess, to the second question of how it happens at the local level. I'm only speaking of the handful I've been involved with here in New Jersey, but it's a combination of having local people, and I'm including, so the way up to the state level. So it's some combination of nonprofits, so the Nature Conservancy or a watershed association, and a state, the state bureaucracy, so it's Department of Environmental Protection or Quality, whatever happens to be in that state. Those local and state people really drive the dam removals. If they're not behind it, it's not going to happen. It also depends on what happens with the dam ownership. There are often times where individuals own these dams and aren't totally aware of it, which is unfortunate. That's a huge liability. So I think most of the dams that have been removed up to this point, and the Northeast, remember, was the one that was doing had done a lot of dam removals, and they've still only removed 3%. It's not to mix metaphors here, but it's the low-hanging fruit. So it's the old, crumbly, short dams that have been removed for the most part. Speaking again here in New Jersey, there are some rivers that they're working on reconnecting anadromous fish to migrate up. So these are things like shad that come up the Delaware River And they've been working their way upstream, which makes sense. And they know that in this one river in particular, there's going to be a dam coming up that has really historic significance. It's part of this old canal system, and that one's going to be a huge issue to remove for all kinds of other societal issues. So I think it's the ones that have been kind of easy and opportunistic ones that have been able to be pulled, at least in New Jersey. And if you made me guess, I would say that's fairly consistent across the nation, but that's a speculation on my part.
Thanks. Well, thanks again for the fascinating talk.
Oh yeah, you're welcome.
Great, yeah, and we've been getting questions in through the chat here. So I was going to start out with, so Erica Groh asks, so she says, thank you for an excellent talk. Could you speak to how you dealt with census data bias that more white people tend to respond than people of color, and how and whether this would affect your results? That's the first part of the question. And the second is there another way to get racial data for environmental justice studies?
We did not deal with any kind of bias in the census data. We took the census data kind of as is. We realized that the data sets are not perfect, but we're kind of relying on the status of those data sets kind of being what they are, both the American Rivers, the National Inventory of Dams, and the census. Are there other demographics? I'm sure there are other ways to do it. There is their annual updates, so if people don't want to wait around for the decennial ones, but yeah, I don't know of those others.
You want me to hop in on that one a little bit, Josh?
Sure, I'll introduce my co-author / dad, who happens to be right below me on my Zoom Hollywood Square format here. Go for it, co-author.
There are indeed American Community Survey updates of census information. And those, however, are based on relatively small samples. And those 5-year moving averages can be used to get updated estimations with bigger errors than the decennial census numbers for a variety of population characteristics. So it would be possible to try to match more exactly the estimate for population of, let's say, 2015 with the dams that were removed in 2015. That is a tweak that we could do to our procedure that I'm not sure would change the overall story that we're getting, but it is an alternative way to analyze things. You're absolutely right.
Awesome. Well, thank you.
Great,
both.
thank you.
The underlying father-son tag team on this issue is quite fun to watch.
Good. We've had a lot of fun too.
So our next question is from Andrew Wilcox. He says, thanks for the talk, Josh. Dam removals can have negative short-term effects, downstream movement of contaminants, for example. Any thoughts on differential distribution of those adverse effects from an EJ perspective? Similar, he's piggybacking on Joel there. Yeah, no, that's a really good point. I think they're possible, certainly. I haven't investigated them. When I've, again, the handful of ones I've been involved with here in New Jersey, they have been really careful about removing the sediment behind a dam. I would even advocate too careful. We've had a few dam removals that have had contaminated sediment, and obviously that should be removed. But they've even removed sediment that is not contaminated. They're worrying about silting up of gravel and silting up of fish beds. And I would advocate that the rivers are more than capable of transporting those fine grains downstream and out of the system quite easily. But so the ones I've seen have done that, but it would be really interesting to see what are the downstream communities affected by this. And that's something we haven't really approached yet, because we looked at the census tract where that dam was. And there were a few times where we came into issues where often waterways are the boundary between census tracts, just like waterways are the political boundaries. And so, we have thought whether or not we should use a buffer around a dam to try and get at some of those effects. And maybe we could look at some of those effects as they kind of propagate downstream. It is something that we've discussed and haven't really come to a great conclusion on, is what's the
what are the spatial effects? They certainly would be a more immediate next to that dam, but then they gradually be reduced as the farther you go. But what that reduction is, you know, not really sure. But yeah, looking at those downstream effects would be pretty fascinating.
Awesome. Yeah, and we have plenty of questions here too, and lots of time. So another question we had from Mirko Musa, she was asking, I was wondering if you looked at the reason why dams were removed, and whether or not you looked at the cost of removal versus the wealth of that area.
Have not. I don't think the database has a lot of information on the cost of the dam removals. I'd have to double check that, but I'm pretty sure, yeah. There's my co-author shaking his head. So no, I mean, that is one of our working theories, is that the local resources, and I mean that both in terms of economic resources as well as kind of political resources, I think has a huge role in which dams are getting removed. So I think there's a lot there that has that local story, has a lot to it in which one of these dams, you know, whether it's local residents that are advocating for these removals, if it's a local resident who has the power to, if a dam removal is being proposed and they don't want it, if they have the ability to, you know, hold hearings and petitions and those kind of things, if they can then stop the dam removal. I've seen that happen where a private landowner, he would have had the dam removal paid for him, but he spent tens of thousands of dollars restoring the dam for purposes I'm still not totally sure why. So those local controls could be really strong, and I think those local resources do have a strong impact on which dams get removed and which ones don't.
And if I could add to that, and also related to an earlier question about next steps, we are thinking about trying to add additional economic information about the census tracts where dams are removed, because part of the environmental justice movement is not just about race and ethnicity effects, but also class effects. So we could ask the question, do dam removals disproportionately benefit higher income communities, not just white communities? And so we want to investigate that. Also, on the very long-term project menu that we have for ourselves, we want to look at how dam removals influence local property value changes. And so hopefully we come to the point of being able to quantify in dollars and cents what's a dam removal worth, and then combine that with our racial justice perspective, which Josh has just introduced, to try to get a sense of, well, not only might disproportionately white areas being benefited from dam removals, but the value to them in dollars and cents of property value increments is X dollars, to try to get that kind of quantification of environmental injustice, if you will, from dam removals.
This next question is right in this theme, and it may be repeating some themes here. This is from John Major, and it's dam removal is commonly driven by an economic balance, revenue versus cost to operate. Did you look at how economics say requirement to add a fish passage drive removal?
No, I completely agree that those economic are really important, but I don't think we have that data available to us, unfortunately. But that would be, yeah, ridiculously interesting if we could include it, because that is a huge driver for where we're, you know, how these dams are being removed.
Great, yeah, and we had another great question, from Emma Harrison. So she was asking, have you looked at this problem in reverse, as in where have dams been constructed and have they displaced communities of color disproportionately?
We have not. That would, yeah, that's a fascinating way to do that too. That's certainly happened with all kinds of other infrastructure projects, highways, and that would be really fast. I'm trying to think of, my wheels are turning. How did that would be done? We would need some census data that would be existing sort of pre and post dams. It's possible, and that would be certainly fascinating to do, because I'm guessing it's you know, the displaced population would be more heavily community of colors, as well as you know, those with less economic resources. But yeah, that would be certainly something worth looking into.
I love that suggestion. We, coming from the urban field, of course, know about urban renewal as a primary term, a policy used for improving housing markets in inner cities and how that had a disproportionate racial impact. But I don't think that's ever been applied to dam construction. Josh, do you? That's
not that I know of. I haven't seen, little bits of, these populations were displaced here or there, but more kind of individual case studies as opposed to larger.
Should we cut off questions now, Josh? Because we have too many research things already. We can't.
I know. And this is the other thing. So my dad retired like a year ago, basically, and so did emeritus. And so he has a man keeping up with them. And like, I'm still teaching course anyway. So it's fun. But let's say his email responses are a little faster than my email responses.
Well, maybe we can do one last one if
I'm joking.
No, yeah, Scott. You don't know my dad well enough. So keep asking questions. We're totally fine.
All right. So the next question from Colin Sastav. Hopefully I said that correctly. And they say, great presentation. I was interested when your model showed that hydropower dams were more likely to be removed. Would you mind explaining again how you saw that in the data? Since there are so few hydropower dams compared to recreational dams, I would expect removals to be more likely to be recreational dams. Are you just saying that the percentage of hydropower removals is greater than the percentage of hydropower dams in the population? Thanks.
Yes, the last question is what we're saying. So I happen to have that slide up in my talk. So of the dams that existed, a little over 1% were hydropower as the primary purpose, but 11% of those that were removed were listed as hydropower. So those were removed disproportionately more than others. Whereas, say, recreation, about a quarter, 24% of the dams listed had recreation as the primary purpose, but those only accounted for 17% of the removals. So there's a shifting going on, and I was a little surprised by that. I would have thought that as people value hydropower more and more these days, but maybe that's other factors coming in. A bit like what John Major suggested, those other economic factors like fish passage. And, I don't think those were very valued when many of these dams were constructed, but we value those more currently.
Right. And what the multiple regression ordinary least squares that Josh talked about does is it asks whether that disproportional probability that it's going to get removed, let's say if it's a hydro dam that Josh just explained, does that kind of statistical relationship persist when other dimensions of the dam are also controlled for, the age, the height, and the type? So yes, you can see these probabilities. You can kind of guess what they're going to turn out to be based on those raw differences in percentages of existence and removal. And the OLS just tries to see whether that persists in a multivariate context.
Yeah, and we had another question. So is it possible that there's a relationship between dam age and dam use? And then in other words, are older dams more likely to be for hydropower? And this is from Mary Savina.
I didn't look at that, Josh, sorry.
I'm going to say, no, I don't think we've looked at that. In terms of our control variables, what were our groups?
What we did look at is whether those variables that we used as controls, purpose, type, age, height, whether they were so highly correlated that they couldn't be disentangled from one another, and that was not a problem. So it's not like there's a super high correlation among those things. Whether there's a positive or negative correlation in some intermediate range, we just didn't check on those correlations, and that's certainly something worth doing. Good suggestion.
Right. Although it was, even controlling for age, hydropower dams were still more likely to be removed, the primary purpose. So there may be correlations, sort of age correlations with older dams being built for a particular purpose. But even when controlling for age, hydropower was still more likely to be, hydropower dams were more likely to be pulled.
Right.
Great. And from Kate Abbott, we have the question, as a follow-up to the previous question, does the hydropower designation include legacy hydropowers such as mill dams that are now obsolete?
I would assume so. It's what was in the National Inventory of Dams, so I would have to go into the metadata. But yeah, I believe it is both like hydropower for hydroelectricity as well as hydropower for mechanical energy. So
that's exactly right. Yeah, when I was looking at some of the micro data on dam removals, and you look at ownership, which is sometimes actually written out, yes, it was XYZ Mill in Fall River, Massachusetts, that was listed as hydropower. And I could just picture this wooden wheel at one point connected to the dam, as opposed to a turbine.
Great. Well, this has been such an awesome question-driven conversation for this talk. I'd like to, if someone has a final question, they can type in there that they're writing it out or raise their hand or something. But otherwise, I'd like to thank Josh and George. I'd like to thank you for hopping on the call. Once again, this has been very fascinating, thought-provoking, clearly by the outstanding questions we've had. And I just wanted to say thank you again. And to answer the final little question in the chat, this conversation has been recorded. We'll post it online. Feel free to share it widely. This has been a great conversation. We would like to everyone be able to see it. I'd like to give everyone one final reminder to join us on January 13 for a science talk from Dr. Danica Roth. And thank you all one last time, and we will see you next time.
Okay, thanks for the invitation. Thanks for the questions, everybody. Take care.
Thanks all. I'm going to end the meeting. Thanks, Josh.
Yep.
And thanks, George, for jumping on.
Yeah, thanks again for the invite. It was really great to be included. So, and great work, pulling this all together in this topic. So I think what you're doing is really great. So we'll see you in January, I guess, right? I was paying attention. So
see you around.
All right.